All right, so yesterday we used the little manipulatives in order to figure out how to write chemical formulas, right? If it was a +3, did you notice it was a great big card? And if it was a -1, it was a teeny tiny little card. That was in order to get you kind of like a visual representation of what we're going to do today. Today is it. I'm going to teach you how to write some of these words. Just some, not all. Just some of these words, okay? The type of words that I'm going to teach you first are called ionics. Ionics always take place between an atom wanting to give electrons and an atom wanting to take electrons. All right, so let's unpack that. What are atoms made up of again? Can anyone raise their hand and tell me what atoms, what elements? Two things atoms are made up of. Of course, some of you are going, I thought it was 3. Yeah, one of those is really not important to us. Jerry's. Protons and neutrons? You chose one that was poor. You chose pillows. Don't need pillows. Oh. Lindsay. Protons and electrons. Protons and electrons are the key, right? That's what we learned. That's what we've learned this week. That if you have the same number of protons and electrons, that's one thing. If you have more electrons than protons, that's another. If you have more protons than electrons, that's another. So it is the number of electrons that actually give you your personality. It is the number of protons that give you who you are, period. All right? So the two things that are important to us when it comes to chemical reactions are protons and electrons. Protons and electrons. All right, here's a question you should be able to answer. Raise your hand. When we say that an atom is neutral, what do we mean? What do we mean? Jack! Same number of protons and electrons. Now, in review, for those of you who are still wondering, what happened to the neutrons? Well, think of the neutrons as those pillows that fit between the protons in order to ensure that they stick together. Without neutrons, you can't have a nucleus. But remember, it's still protons that do all the heavy lifting. Neutrons just allow protons to live together. All right, next question. What are ions? What are ions? Raise your hand. What are ions? What are ions? Carter. Atoms with a charge. Can you be more specific? What would cause an atom to have a charge? Carter? Differing amounts of protons and electrons. Not quite what I'm looking for, but pretty dang close. Basically, an atom that has given up or taken electrons, that's an ion. That is what we call an ion. That is an ion. So an atom has equal number of protons and electrons. An ion will either be a positive thing or a negative thing, depending on whether it gave electrons or lost electrons. All right, so when you gain electrons, you become smelly. Why do you become smelly when you gain electrons? Yes? Because electrons are a negative thing. But what about the smelly? Because you become an anion. And an anion reminds me of an onion. Right? And remember, an onion has like the little lines, the little layers. So the little lines kind of remind me of electrons. And an onion reminds me of the word anion. So an anion is something that has gained electrons. For example, chlorine normally is made up of 17 protons, 17 electrons. But when chlorine atom becomes an ion, it gains an electron. It gains an electron. So, anions, onions, smelly, negative. It's not good to be negative, is it? To be smelly. People would look at you and go, I need to wear a mask. Sandra's over there going, I wish Terrence wouldn't smell so bad. I wish he wasn't an anion because I have to wear a mask now because of it. Either that or stop breathing for 90 minutes, right? Terrence, use soap, man. Deodorizer, deodorant, antiperspirant. Yeah, whatever. All right. What about if you're positive? Meow. 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 Oh, cat pee is bad. So, whiskers. Whiskers. Everyone's a critic. All right, so a cation is one that has gained or lost electrons. Who remembers? Amy says?
I don't know.
It's a 50-50. Yeah, you guessed right. Lost. Okay, so, for example, sodium. Nope. Sodium has 11 protons, 11 electrons. But the ion sodium has still 11 protons, 10 electrons. And that is why it is a positive 1 charge. A positive 1 charge. Okay? Sodium. Cations. Chlorine. Oh man, smells bad. Anion. We good? There is not going to be a difference between the name of an element and its cation. But there is a difference between the element and its anion. What is that difference? Okay, at this point, we need to become politically incorrect and unwoke and all that stuff, and use an analogy to help us remember what is what. Remember that zigzag line I told you about yesterday? That zigzag line that begins around boron and goes between aluminum and silicon and arsenic and germanium and antimony, tellurium, polonium, and astatine. That is the dividing line between the, which I think of as guys, and you'll understand here in a second. And on the right side, you have Hugh. She's smelly. I think of those as the girls. Why? Because in a traditional marriage, who always changed their name? The females. That's right. So the anion, man, is going to change her name to make it end in IDE. To make it the name end in IDE. The cation, the guy, traditionally, he doesn't change his name. So that reminds me, don't mess with the cation's name. Don't mess with the cation's name. Leave the cation's name alone. All right. Some examples of girls and how they've changed their names. Chlorine becomes chloride. That one's easy.
Is that the bleach we be buying?
The bleach you're buying has chlorine in it, but it is not pure chlorine. Pure chlorine is too dangerous to mess with. It is a compound that has chlorine in it. Now, Things do get confusing because you would think that oxygen should be oxygenide, but we chop off most of oxygen and just call it oxide. Oxide. But you know what? If you were to write down oxygenide, I'd be totally cool with that. Oxygenide is fine. Nitrogen is in the same boat. We kind of chop off the whole ogen and just add the IDE, so that becomes nitride. Nitride. So girls, the right side of the zigzag line, the non-metals, girls change their names to IDE. Guys don't change their names. So, sodium loses an electron, so now we call sodium what? Sodium. Sodium, because cations do not change their names. Magnesium, if it loses 2 electrons, now we call magnesium what? Magnesium, because cations do not change their names. Aluminum, if aluminum loses 3 electrons, we now call aluminum what? Aluminum. You guys are not getting the pattern. Because if you lose electrons, we don't change your name. Okay, I'll show you. There is a lot going on. If you're interested, I will show you. Okay, so here are all the electrons. Boom, 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 boom. If you lose 3 electrons, you have less electrons, so it kind of reduces the cloud. And here are the 3 electrons leaving, going away. Okay, so since the cloud represents the electrons, since you lose 3 electrons, you don't have as big a cloud. Yes?
So if you lose electrons, it's the cat thing, right?
Yes, you become a cation, and you don't change your name. As opposed to this Con-Air, notice the cloud gets bigger because what are you doing? You're gaining an electron. Gaining an electron. Anions do change their name. So this is chlorine. This becomes chloride. Correct. You're positive, you don't change your name. You're negative, you change your name. Are we good so far?
This is confusing.
Well, it's about to get more confusing, so hang on. Here we go. So, how do we know whether a cation is going to lose 1 or 2 or 3? And an anion loses 1 or 2 or 3. How do we know these things? I've had some anions that have been -2 and some anions that have been -3. How do we know? Well, we look at our best friends, our periodic tables. That's why I keep telling you, make sure your periodic table is out. And if it's not out, it needs to be out now because we're about to mark it up. We're about to mark it up. The periodic table can tell us whether an element is a cation or an anion. That's easy. Zig, zag, line. Anything on the left? Cation. Anything on the right? Anion.
Can you show us where the zigzag line is again?
Yep. I'm going to put a periodic table here in just a second. You missed that yesterday. But on the positive side, you have no cavities.
And the what?
Cavities. She has no cavities.
What are we talking about?
Wait, go back.
Linseed oil. We're talking about linseed oil. What?
That is the weirdest name ever.
That's what happens when your teacher is a chemistry teacher and is actually familiar with linseed oil. And your name, Lindsay, reminds him of linseed oil. You probably have never had a chemistry teacher as a teacher before. Okay, I have stalled. Have I stalled enough? Excellent. Now, how can you tell about their charges? Put these things down. I think it's just, you're just writing in pieces of information, right?
Where are you at?
Number 11.
Keep up, teacher.
Aren't you just writing down? Okay, so there really shouldn't be any whining.
These are the charges.
They are the charges. So you have it down on paper in your notes, but now take out your periodic tables, take out a pen or pencil, get ready to add critical information to your periodic tables. For example, here on top of that first column, put a +1. Everything on that column, in that column, I don't know what the right preposition is for, is a +1. Okay, move one over. Put a big fat +2. On top, right there, on that periodic table, right there, put a +2. Over here on the extreme right, yes, they are anions. Yes, they are nonmetals, but they won't form. Think of them as Catholic nuns. They are not going to get married. There is no giving. There is no taking. Bam. They're going to be always found in their natural state. Move one over to the left. That whole column, -1. Linseed oil. Do you see now the zigzag line? Make it darker on your periodic table. That's what I asked them to do yesterday. Excellent. So everything on the right is negative. Everything on the left is positive. That's why I color-coded these things. So -2 really is only for these three. Do not write that line down. So -3 is only for those. -4 is going to be, and +4 is just going to be for those. +3 is only, okay, so the yellows are kind of weird. So in the box itself, put +3, +3, +2, +2, +1. If you're wondering about the pinks, tell me about the pinks, Mr. Moreno. What's their charge? You are not mature enough to understand that.
You mean mature?
You're too immature to understand that.
30.
Those are +3, +3, +3, +3, +2, +2, +1. But on Monday, if you're wondering, when will I be mature, Mr. Moreno? Monday you'll be mature. Yay, Monday. Monday's your day. Monday, Monday. Da, 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 da. Okay, here we go. We're going to use this. You ready to write some chemistry words? Well, I'm glad you're not ready because we're doing it anyway. So, how do we write ionic formulas? There should be step 1 through 4, right? Most of it should be written for you in the notes. Step number 1, write the symbol of the metal, the guy, with his positive charge. Remember, we're thinking of guys as positive. Positive. Next, write the symbol of the nonmetal, the girl, with her negative charge. With her negative charge. If the charges are the same, one is positive, one is negative, but they're the same, you're done. You're done. Get rid of the charges because the charges are just there to help you. Get rid of the charges, and that's your answer. Now, if the charges are different, crisscross.
Enthusiasm.
I love this stuff. This is cool stuff. Crisscross. All right, we're ready?
No.
Wait, no.
Oh, no, we're not ready yet.
I'm ready.
It's
but
too hard to write down crisscross.
Alright, I'm done.
Okay, everyone done now?
Yeah, we get it.
Always wait.
We are good, not we good. There's you need to have a linking verb
I
there.
thought you weren't an English teacher.
I'm not, but I understand English. English is my second language. All right, here we go. You ready?
No.
Well, we're going to go on whether you're ready or not. Okay, so I look up sodium on the periodic table, and I see that the symbol is Na, and its charge is
1.
+1. I look up chloride, and there's no chloride, but I bet, her name was changed. I bet that was chlorine. So I look up chlorine, and she is a -1.
Wait, what? How you go from chloride to chlorine? Is chlorine an element?
Chlorine is on the right side of the zigzag line. It is a girl, and girls, when they get married, change their names to IDE.
Okay.
All right. Focus on the charges. Are the charges the same?
No.
Same number, opposite sign.
That's what I meant.
Done. Having stylus problems. Hold on. Keep in mind, whoever yawned so loudly, that I am recording this, and people in the future will wonder, who is that guy yawning so loudly? All right, that's it. NaCl. NaCl. It's not NaCl, it is NaCl. NaCl. Notice, I don't have any ones here. There's no ones anywhere. Ones are always understood. Notice, there are no uppy numbers. I hate uppy numbers.
So what do they put up? You put up the number.
In order to get it in the right order, in order to know how many of each. So they help you get to the final answer, but they are not part of the final answer.
Okay.
What? Terrence, you want another example? Oh, I've got plenty of examples. How about this one? Potassium. Potassium is the first element there. I would look for it on the left side of the zigzag line. Okay, it's a guy. It does not match its name. It is K, and its charge is +1. Oxide kind of reminds me of oxygen, and you know what? There is no other element that's like ox anything. So that has to be oxygen. So oxygen is a girl, and her charge is -2. Savage. Are the charges equal? No. Crisscross. What do I mean by crisscross? First of all, the charges already did their job. Don't need the charges. Okay, second of all, crisscross. That's what I mean by crisscross. So the charge of potassium becomes the number on oxygen, and the charge on oxygen becomes potassium's number. Some of you yesterday noticed this. I know you noticed this because you were done within 30 seconds. Who, raise your hand, who noticed that? Yeah, yeah. So, yeah, I could have taught you the crisscross method yesterday, but you would not have understood the concept behind it. you would not have understood the concept behind it. So the final answer is K2O. So let me explain it again. K plus oxygen, -2. Criss-cross. Ones are understood. So you don't need a 1.
So that becomes instead
The
of
answer, the
negative,
final answer.
positive.
Positive and negatives, we don't care. We don't care about the positive and
So
negatives.
just write the number.
Correct. And notice, no uppy numbers. Uppy numbers are going to drive me crazy, and I will count them wrong every time. The whole thing is wrong if you have any uppy numbers.
Can you do one more example?
No, I will do many more examples. Barium +2. Chlorine Cl -1. Are the charges the same?
No.
No. Crisscross.
So it'll be
Roop.
BA2. No, BA1, CI2.
Well, if by I you mean L, yes.
Okay. So what happens to 1?
Ones are understood.
Okay.
They're there. It's there. Can you see it? It's there. It's just not there.
It used to be there.
It used to be there. It's just not there.
What, man?
TA, you ready to help me with this one?
I can try, bro.
All right. Magnesium, symbol, charge.
Mg +2.
Sulfide, probably sulfur, symbol, charge.
Let me find sulfur real quick. S. What's the charge?
Look on top of the periodic table, on top of that column.
Next to E.
All right. Question number 1. Are the charges the same?
Oh yeah, that's the same E.
So your answer is get rid of the charges. Don't need them anymore. That's it.
Oh. Hey, they have it.
Wait, hold on.
Should I see any positives or negatives in your final answer? No.
Wait. We got 2 on both sides, but where's the 2 on the down knee?
Step number 3.
Huh?
If the charges are the same, done.
Oh, they just cancel out.
Cancels themselves out. If the charges are different, crisscross. All right. Who would like to try this one?
T-trap.
Come on. A brave person. Lindsay, go. Aluminum, symbol, charge.
AL +3.
By the way, this is as hard as these get. No, this is easy. Never mind. You got an easy one. Nitrogen, probably. Nitride, yeah, nitrogen. Symbol, charge.
N -3.
Are the charges the same?
Yes.
Final answer.
ALN.
Remember, first letter is capitalized, second letter is lowercase. So capital, lower, capital. Also remember, no cell phones. I better not see any cell phones, especially on your lap or underneath your lap.
Oh God.
Sitting on them. Don't want to see them. All right. How about this one? Thank you, Jorge. Aluminum, symbol, charge.
AL +3. CL -1.
Are the symbols the same? Crisscross. The 3 goes where? First of all, what happens to these charges? To the pluses and minuses? No, the pluses and minuses go away, and the numbers will switch. And what about what's your final answer?
AL CL.
What happened to the 1?
Ones are
No, ones are understood. Okay, I believe that the last two examples that Terrence wants are not on your notes page. So you'll need to add them. 18, aluminum oxide. This one is as hard as they get. Who would like to do a hard one?
Me.
All right. Terrence, aluminum, symbol, charge.
AL.
Charge.
Charge will be a +3.
Oxygen, symbol, charge.
Oxygen will be O, and it'll be a -2.
Okay, at this point, remember, the pluses and minuses have done their job. They've allowed us to put them in the right spots.
Okay.
So no more pluses or minuses. Are the charges the same? Are those numbers the same? Crisscross.
So it'll be aluminum, AL, right? And then we're gonna do 2, and then we're gonna do oxygen, and then we're gonna do 3.
Whoa.
Just like that. Simple.
Whoa. I think that one definitely deserved a boom.
Blow it up, bruh.
Last question. Chemical formula for zinc fluoride. Zinc fluoride. I need a new volunteer. A new one. A new one. Thank you, Avery. Zinc. Symbol. Charge.
What is this one?
As I said, Terrence, the last two are not in your notes.
Okay.
Zinc. Look for it in the 30s. Find the 30s. Fluoride is probably fluorine. That's in the ones.
Yeah, F-1.
Have the charges done their job? So get rid of them because I don't want to see any more pluses and minuses. Are the charges the same? Crisscross. What's the final answer? All right, I've got plenty of examples for you to work through. You're working alone. If you run across a problem, call on me. I will come over and help you.